This is lesson number 6 of the chemical bonding storyline. The storyline, officially titled Why Do Some Things Get Colder or Hotter When They React? I've chronicled the previous lessons, including lesson 1 when barium hydroxide and ammonium chloride were mixed. Lesson 2 that involved the solvation of potassium chloride. Lesson 3 that centered around the modeling of this solvation reaction. Lesson 4 that asked students how can you best model the connection between atoms. Lesson 5 during which students model that the breaking of chemical bonds requires kinetic energy. And now we've reached lesson 6 during which students dissolve various kinds of ionic compounds in water. This slide shows you all the various lessons associated with the storyline. Lesson number 6 centers around the following key question. Are all bonds the same? This lesson took me roughly 2 class periods or lab periods to complete, and I taught this during the second quarter of the academic school year. This lesson really enabled me to delve into my chemistry stockroom. As you can see, lots of bottles are present. So many choices to choose from, including chlorides, acetates, other halides, including iodides, phosphates, 2 shelves filled with sulfates, nitrates, and our Arrhenius bases, which include the hydroxides. But I took this opportunity to start very safe and picked from the shelves sodium chloride and potassium chloride and handed it out to several students in my classroom. And this enables you to really have them focus on the hazard alerts. May be harmful if swallowed. Sounds relatively safe. Another ionic compound that I was able to pull off the shelf is lithium chloride. Let's read the hazard alert for this one. Harmful if swallowed. Okay, we weren't planning on consuming it. Causes skin irritation. Causes serious eye irritation. May cause respiratory irritation. Wear protective gloves and eye protection. Wash thoroughly after handling. And then the oral rat LD50, 526 milligrams per kilogram. I chose not to use this salt. If you wish to explore the LD50 values, this particular Flint Scientific Lab explores exactly that and enables students to understand the relative toxicity of different compounds. And although I had many ionic compounds to choose from in my stockroom, I chose these very familiar ones, sodium hydroxide and potassium hydroxide, as I know that these ionic compounds will come back when we get to the acid and base unit. Of course, we should not consider these compounds as non-hazardous, considering the fact that enough heat evolves when added to water, and it can cause severe skin burns and eye damage. Wearing goggles is thus very prudent. But having each student in the class look at these bottles, holding them in their hands, unopened, and check out the hazard alert label, it puts the ownership a little bit more on the student as to what safety precautions should be taken when handling these chemicals. So the idea behind lesson 6 is for students to dissolve a small amount of each of the 4 different ionic compounds in a set amount of water and observe the temperature change. What you can see here is that about 6 grams of sodium hydroxide was added to close to 30 grams total of a solution. The starting temp was 22.8 and the final temp 54.6 degrees Celsius. Recording all that data in a Google Sheets allows you to easily see that for the 4 different salts, there is clearly a difference in the change in temperature in degrees Celsius. And that will allow students to answer, are all bonds the same, in a quantitative manner. Subsequently, turning that data into a bar diagram gives you the following visual. This data clearly shows you that potassium chloride and sodium chloride are slightly endothermic, whereas the solvation of potassium hydroxide and sodium hydroxide are definitely exothermic. If you wish to get more help manipulating this data in Google Sheets, check out the link above where I go through exactly that. In a previous lesson of this very bonding storyline, we've already modeled the solvation of potassium chloride. The hydration of ionic compounds in water not only involves the disruption of the hydrogen bonds between water molecules, but it also involves the breaking of the ionic bonds between the cation and the anions. Lattice energy, how much energy is needed to break the ions away from each other. But the final step in a solvation reaction is when these ions mix with the water molecules. We can refer to that as the hydration energy, how much energy is not absorbed but instead released when the ions are surrounded by water molecules. Lesson 6 of the chemical bonding storyline focuses on are all bonds the same? And because students are dissolving various ionic compounds in water and notice a difference in the temperature from the beginning to the end of the solvation reaction. And this observation clearly underscores that no, not all bonds are the same. At the end of lesson 6, students are asked to connect what they've observed in this lab relating to the hydration of various ionic compounds to the two chemical reactions that they did during the very first lesson. Why again did these two reactions result in a temperature drop? And that leads lesson 6 right into lesson 7. Why did barium hydroxide and ammonium chloride absorb energy, which brings us to the halfway point of this chemical bonding storyline. Stay tuned for that one. In conclusion, lesson 6, the chemical bonding storyline, enables you to dissolve various kinds of ionic compounds in water, and students can observe the changes in temperature, whether it's a rise or a drop compared to the starting room temperature. It also gives students the opportunity to become familiar with the actual chemical bottles and the hazard labels. And it enables you as a teacher to emphasize the safety procedures needed when working with these various chemicals. And you can choose yourself how hazardous or non-hazardous you wish to make this particular lesson by picking various chemicals for students to dissolve. As always, this storyline centers around two key next-gen science standards, including matter and its interactions, as well as energy change in components of a system. A storyline in Dutch is a verhaallijn, verhaal story, lijn line. The red thread, de rode draad, connects all these lessons to each other, really having one lesson built upon another, so that students are not just exposed to random facts, but instead learn these concepts in an interconnected manner, and that might help them remember it better. If you wish to have these resources or any other resources that I've created YouTube videos about, including lesson handouts and their keys, check the link in the description below. In exchange for your email, you can use these handouts in your classroom with your high school chemistry students. Thank you very much for watching. Bedankt voor het kijken en tot ziens. See you in the next video.